Problems we're going to go through in this video are listed here: 1, 8, 9, 10, 13, 15, 16. You can skip around, watch whatever you need. You have the answers for all of them. If there's any other questions you guys would like for me to go through, the sooner you send it, maybe I'll be able to get a video, but it's not guaranteed at this point for that, all right? So we're going to go through all these. And for this first question, number 1, I'm going to minimize, once I have the question, I'm going to minimize it and kind of do it off to the side for the most part. But this one, it's really just, there's a specific standard that we have to cover of knowing that minus can be rewritten as addition and that this is actually a negative 852. So you have to show me that in order for you to get full credit for this standard, which most of you already have done. So we need to rewrite it as an addition problem. So then instead of it just saying minus 852, we need to rewrite it as plus negative 852. After this unit, you'll never have to do this for me again. It's mainly just if you have trouble seeing that that 852 is actually negative, which means that we can add the negative as well. For future references, though, I do think that this makes it a little bit more confusing as we solve certain questions. So after this unit, you don't have to do this again, but is this allowing for you to see that this 852 is actually negative? All right, so now when we're adding or subtracting, we first look at our signs. When they're the same, we know that we can just treat it as an addition problem, and we just add the two numbers together, because if you owed me $314 and I lend you $852 more, you still owe me money, so you'll still be in a negative. They don't magically turn to positive when we're adding or subtracting. That's when we're multiplying. So it's important for you to slow down and think about what operation are we doing. So we just add down, that gives me 6, 6, and 11. So this is negative 1,166. All right, but you must show this on your test to get full credit for that standard. All right, so next question, number 8. It says the temperature at 5 a.m. was 44 degrees Fahrenheit. Throughout the day until 10 p.m., the temperature rose 25 degrees and then fell 31 degrees. What was the temperature at 10 p.m.? So throughout the day, our temperature was fluctuating. It started out at 45, it rose, it fell, rose, it fell. But in total, it rose 25, and it fell 31. So how do we represent something that's temperature that's rising? Is that a positive or a negative? Well, when we rise with temperature, that means that we're adding to it. And when a temperature falls, it means we're subtracting. So at the beginning, when we took this temperature, it started out at 44. And then it rose 25 degrees throughout the day. So we can add that together and get 69. And then from there, it fell 31 degrees throughout the rest of the day. So then we subtract 31 from that 69 to say, okay, well, then this is equal to 38. So throughout all the fluctuation, throughout all the day of going up and down to temperature, in total at 10 o'clock, it was 38 degrees because it fell 6 more degrees than it rose throughout the day. So therefore, at the beginning of 44, we just need to remove that 6 from it. And you can do it in different ways. You don't have to do it the exact same way I just did here, but that is your answer there, 38 degrees Fahrenheit. All right, this next one, x minus k, that's what we're substituting in for. So it's x minus whatever k is, k. X was equal to negative 25.6. So when we're substituting that in, that x is equal to negative 25.6, so it's minus 25.6, so negative 25.6. Then the original problem was x minus k. So that minus is part of the original problem. So that still needs to remain as it is. And now it's minus k, which k is equal to negative 78. So it's minus 78. So I think some of you, if you're getting this wrong, you might have just said x minus k and wrote it like this, negative 25.6 minus 78, because you saw the negative and just said, oh, okay, it's all one and the same. But we're subtracting whatever that k is. And now we know that when we subtract the negative, that's the opposite of the opposite. So we know that they cancel out, or it's a double negation. And we know that this actually turns to plus. So then we know that this is going to be negative 25.6 plus 78. Now when the signs are different, we subtract. So 78 minus 25.6. And then from here, we can add the 0 after that 78. And now we're just going to go ahead and subtract like a regular problem that you guys learned before. So 10 minus 6 is 4, put our decimal, 7 minus 5 is 2, and 7 minus 2 is 5. And since the larger number was positive, when we were doing the adding of the different signs, we know our final answer is positive, so it's 52.4. All right, so for these problems, I'm going to convert all these into improper fractions. Just when you're multiplying, you need to do that anyway. And in the future, we usually have everything as improper fractions, and it's not really written as mixed numbers anymore. So just getting in a habit of how you might see this in the future anyway. So to convert these, we multiply and add. So this will then give me 6 plus 1 is 7 over 2. plus or minus, so negative 7 over 2, sorry, minus 4. And then here we multiply and then we add. So this will be plus 19 over 8. So when we are adding or subtracting fractions, I'm just going to focus on this now, is we need to have common denominators. If we don't have common denominators, then we're not trading equal parts. So if I have a candy bar and I break my candy bar into halves, but you keep yours as a whole candy bars, it doesn't make sense for us to trade one of my halves for one of your wholes. You're not getting an equal deal on that. So we need to make sure we're breaking everything equally. So I'm going to first focus on the first two fractions, so negative 7 halves minus 4. And we know that we can write every whole number over 1 because 4 over 1 is still 4. And now we say, okay, our denominators are 2 and 1. What's the common denominator between them? That's 2, or the least common denominator. So I'm going to multiply it by 2 over 2 because 2 over 2 is 1. So I'm not changing the value of that 4, I'm just manipulating it. So it becomes negative 7 over 2 minus 8 over 2 because 4 times 2 is 8 and 2 times 1 is 2. So now I have equal parts. You broke all your candy bars now in halves as well, so now we can trade. Well, now we look and say, okay, when that happens and we have the same denominator, we now just add or subtract our numerator. So it becomes negative 7 minus 8, which is then negative 15. So I know that that's going to be negative 15 over 2. I can't simplify it all. So now it remains as is, and now we need to add it with that 19 over 8. Once again, our denominators are 2 and 8, so I can turn this 2 into an 8 by multiplying it by 4. So I multiply by 4 over 4 because that's 1, so we're not changing the value. So now it becomes negative 60, which is 4 times negative 15, over 8 plus 19 over 8. Once we have the common denominators, we now know we can add or subtract our numerators. So this becomes 60 minus 19 because the signs are different, so we have to subtract or add, or I'm sorry, we have to subtract. And we do the larger minus the smaller. So then we can borrow from the 6, so that gives me 1, 4. The larger number was negative, so that means our final answer will be negative 41 over 8. There's no common factor, so we can't simplify this. So you can leave it as improper fraction. If you really want to, you can write it as a mixed number, but I would suggest getting in the habits of working with improper fractions more now than mixed numbers, because as you move into algebra 1, pre-calc and all that, it's going to be as improper fractions mostly. All right, so for number 13, it says to evaluate the expression. So one of the things is when people see PEMDAS, they usually say, okay, well, multiplying has to happen first because it comes first, and they might multiply these two numbers together and then go from there. But when we're doing PEMDAS, it's important to remember that multiplying and dividing, multiplying doesn't necessarily come first, it's left to right. So as we move left to right in a problem, that's the order that we do it. So we look and say, okay, left to right, we're going to do everything that we can as we go. So the first thing that happens is the multiplying. So then we will say, okay, well, 5 times negative 7. Well, we know that when we're multiplying, it's the same as repeated addition. So this is saying adding negative 7 together 5 times. Or as we learned, a positive times a negative is negative, so it will be negative 35. And now it's divided by 1/4 and times negative 3. Once again, we continue to work left to right. So that means now we're going to do the division problem. So it becomes negative 35 divided by 1/4, which we know our rule is keep, change, flip. Yeah, that's the action. Everybody knows how we're dividing fractions. So we keep the first one, we change the multiplying, and then we multiply by its reciprocal, so we flip the fraction. And now negative 35 times 4, well, we know it's going to give me a negative as my answer because a negative times positive. And 35 times 4, that gives me 20. 12 plus 2 is 14, so it's negative 140. And then what's left is timesing it by negative 3. And we know that when we multiply two negatives together, that's like a double negation. That means that they undo each other. It's the two opposites. They undo each other. And it's going to give me a positive answer. You do not need to, and I will suggest not writing the plus sign. I'm just reiterating it's positive. And then we do 140 times 3. So 0, 12 carried to 1. 3 plus 1 is 4. So it is a positive 420. And that will be your final answer. All right, but sometimes people just think multiplying has to come first. And if you multiplied this together first, your answer would not have been correct. All right, so this question is a little bit more in depth and takes a little bit more to solve. There's quite a few steps for this. One, it says a city aquarium has 820 fish, of which 35% are saltwater and 65% are freshwater. Each saltwater fish costs $1.90 per day to care for, while each freshwater fish costs $1.55 per day to care for. How much money does the aquarium spend in a week to care for both types of fish? All right, so the information is given to us in two different ways. One, we don't know how many saltwater and freshwater we have, so that's something we have to figure out. Two, it tells us how much it costs per day for each of them. And then 3, the final answer is asking for, well, how much is it a week? So there's a few different conversions that we have to do here. So first, we need to figure out, well, if we have 820 fish and 35% are saltwater and 65% freshwater, we need to figure out how many that actually is. Like, how many fish is it of each one? Because we have to figure out, well, how much does it cost to care for them? Because they're different prices for each fish. So saltwater is 35%. Well, if we have 820 fish and we know 35% of them are saltwater, we can figure out how many by multiplying. And 35% is 0.35 because we're dividing the 35 by 100, or we're moving that percent sign, if that's how you were taught it, 2 places to the left to turn it into a decimal. So we need to multiply 825 by 0.35. This will tell me how many of those 825 fish are actually saltwater. So then we multiply, I'm sorry, not 825, that's 820. 820 fish. So now we multiply. This will then give me 5 times 0 is 0. 5 times 2 is 10, carry to 1. 40 plus 1 is 41. We put our place value for that 3. And then 3 times 0 is 0. 3 times 2 is 6. 3 times 8 is 24. We add down 0, 0, 7, 8, 2. And we had 2 decimal places. So we need to move 2 decimal places. So that means that of the fish that we have, saltwater, we have 287. So rather than doing the same thing for freshwater, because maybe you might not be as comfortable with multiplying as you are, if we know we have 820 fish and 287 are saltwater, well, I can figure out how many freshwater by subtracting. 820 minus 287 will tell me how many freshwater we have, as long as you trust that you multiply correctly. So now if you want to check your work, you can multiply and then add those two numbers together to make sure it equals 820. And that's a way to check your work as you go. So I'm going to borrow from the 2, that gives me 3. Borrow from the 8, gives me 11 minus 8 is 3. And 7 minus 2 is 5. So that means we have 533 freshwater fish. All right, so now we know how many fish of each type. And now we're going to think about, okay, well, the saltwater fish costs $1.90 per day to care for. So that means if I want to know how much I'm going to pay in total for caring for the saltwater, I need to multiply them. So when I multiply this, it gives me 0, 0, 0. When I go to the 9, I'm going to put my place value. 9 times 7 is 63. 9 times 8 is 72, plus 6 is 78. 9 times 2 is 18, plus 7 is 25. And then when I move on to the 1, I need to put 2 place values now for the 0 and the 9. And then 1 times 7 is 7, times 8 is 8, times 2 is 2. And now I will add down. So it gives me 0, 3, 5, carry to 1, 13, 14, and 5. And I had 2 decimal places, so I need to put 2 decimal places here. So that means for one day, it's $545.30 to care for saltwater. All right, so now we need to figure out how much of the freshwater fish cost per day. So I'm just going to write this over here so that way I have a little bit more space while I'm multiplying. So 533 times $1.55 per day. So this will then give me 5 times 3 is 15, carried 1. 5 times 3 is 15, plus 1 is 16, carried 1. 25 plus 1 is 26. I'll move on to the next 5 now. So I need to put my placeholder because I'm moving on to this 5. When I multiply, it's the same numbers. So it's going to give me the 15 again. 15 plus 1 is 16 again. 25 plus 1 is 26 again. And then the last one, we're moving to the 1. So we need to put the 2 placeholders. So this will give me 3, 3, and 5. We then add down. That gives me 5, 11. 12 plus 3 is 15, plus 1 is 16. 2 plus 6 is 8, plus 3 is 11, plus 1 is 12. And 5 plus 2 plus 1 is 8, so it's $826.15. So that's how much each type of fish costs for the day. So we then aren't solving for the day, though, we're solving for the week. So rather than multiplying twice, I'm going to add first, because I can figure out how much it costs per day for the fish in total. So when I add down, that gives me 5 and 4, it gives me 11, that gives me 6 and 7, and then that gives me 13. So I know total for the entire day, I'm paying $1,371.45 to care for the fish. Well, there's 7 days in a week, so I need to multiply that by 7 to figure out how much I'm paying in total. So this gives me 35, 28 plus 3 is 31, 7 plus 3 is 10, 49 plus 1 is 50, 1 plus 5 is 26, and 7 plus 2 is 9. We had 2 decimal places, so we need to move it 2 decimal places. So that means in the week, it will cost $9,615 to care for all the fish. So for number 16, no one asked for A, but in order to do B, we need to have A done. So I'm just going to go through it pretty quickly. It says how much price change from beginning of 1 to the end of week 4. So if we're telling us how much is changing per week, we just add all those numbers together. To make it a little bit easier for me, I'm going to just add all my positives first. So that way I'm only dealing with the same sign. So this gives me 6, this gives me 11, 13. This gives me 9, and this gives me 1, so 1936. So now I have negative 21.12 plus 19.36. When the signs are different, we then subtract, and we do the bigger number minus the smaller number. So that way we can write it in a way that we're used to doing. We borrow, this gives me 12 minus 6 is 6. Borrow, so 10 minus 3 is 7. Borrow, so 10 minus 9 is 1. The larger number was negative, so that means our answer was negative $1.76. So it means from week 1 to week 4, the price decreased. So for this B, there's a few different ways you can do it. You can logically think about that. So if the price decreased from week 1 to week 4, and it went to 776.03, that means it had to be more in week 1. So it means that we can just add that 176 to the price that they give us of 7.76 and 3 cents, because we know that if it decreased by that amount to get to 7.76, well, it started above it and was greater than. So we can add that to get 9,777. So we know it has to be $777.79. You can just logically think about it. But what we're learning next is expressions and equations. So this can be set up as an equation. Where we started in week 1, the value, we don't know. But we know that from there, it decreased by $1.76 to end up at 7.76 and 3 cents. So we know that this is what happened. Whatever the price was at week 1, it decreased $1.76, and after that decrease, it was 7.7603. So you guys should learn this in grade 6 of solving one-step equations. So we're doing what's the inverse operation. Well, to isolate that variable or that unknown, we need to undo what's being done to it. Well, what's the opposite or inverse of subtraction? It is addition. So then we are adding $1.76. Either way you do it, you're still going to get the exact same answer that we got, whether you logically think through it or you set it up as an equation and solve that way. It's completely up to you which one you feel more comfortable with, but after next unit, I do think it's just easier to set things up as equations than it is to logically think through, because questions just get harder, and sometimes they'll be harder to just like logically think through these questions than just like a subtraction problem. All right, so that is it for this video.